Okay, 7.4. We're adding and subtracting rational expressions with binomial and trinomial denominators. It's really going to be the same thing as 7.3, except now to get our common denominator, it's going to be a little more difficult. So factoring is going to play a big key again in here. 16 minus 9a squared, that's a difference of squares. So we've got 4 minus 3a and 4 plus 3a. Always look for a GCF when you're factoring. Next one, we can factor out a 2. So leaves us with 2b squared plus 5b minus 14. And then some product factoring there down to b plus 7, b minus 2. I'm not going to spend much time on the factoring of these. We've spent a lot of time already. 2c squared, 2c minus 1 and 3c minus 2. Let's get down to this part. I highly recommend that you try these on your own first before you listen to the video. Find out where you're going to make your mistakes. Then you're able to correct where your mistakes are instead of just blindly copying. But actually try to think it through yourself. You'll learn way more by doing that. So I recommend you pause now, try them, and then start it again. Okay, looking at the first one, they have a common denominator already, so we don't have to do anything. Just add them up. Okay, so we get, let's put that one right in there, 5 plus 1, 6 over x plus 3. They had a common denominator, we just add the numerators. But we do still need to do our NPV. X cannot equal -3. Next one. From here, we've got two different denominators. So I'm going to pull that one down and start working it through. 1 over x plus 3 minus 2 over x minus 5. Think of it the same way as if you had, let's say, just 1 over 3 minus 2 over 5. In order to be able to add this one, we need a common denominator. We would multiply by what's missing here to get a common denominator of 15, which would have been 5 over 5 and 3 over 3. We're going to do exactly the same thing, except we have a binomial that we're using. My common denominator is going to be both of them together. So my denominator would be an x plus 3 and an x minus 5. So the first one, in order to get from x plus 3 into both of these, it's missing an x minus 5. Just like we did with just the basic adding, subtracting of fractions. This one is missing the x plus 3. So then we get for numerator here, 1 times x minus 5, and this one minus 2 times x plus 3. Distributing your numbers, x minus 5 minus 2x minus 6. Highlight that one because that's where people make the mistake. Over x plus 3 times x minus 5. Combine all your like terms in the numerator, which is now going to give you x minus a 2x gives you negative x. Negative 5 minus 6 gives you negative 11. Over, don't expand the denominator, leave it in factored form. X plus 3, x minus 5. But we have to do our NPVs. Any denominator that had an x in it, got to do an NPV off of. And for these ones, it's x cannot equal the negative 3 and the positive 5. Next one. 3 over. We want to factor this. X squared plus 6x plus 9. Quick factoring gives us x plus 3 and x plus 3 minus 2 over x plus 3. My denominator has to include what each of them have. The first one has an x plus 3 and a second x plus 3. So x plus 3 times x plus 3 has to be there on the first denominator. The second one has already an x plus 3, so I don't have to add a third one. But it's missing one, so I'm going to have to multiply this one by an x plus 3 over x plus 3. Which gives me for the numerator 3. Didn't have to change that one. It had the denominator already. Minus 2 times x plus 3. If you want, you can distribute that in as long as you take the negative in with it. Or do it here now. Distribute it in, which gives you 3 minus 2x minus 6, or x plus 3, x plus 3. Simplify it as far as we can. Combine our like terms. Negative 2x minus 3 over x plus 3 squared. Comma, NPVs, x cannot equal negative 3. Last one. Okay, so 5 over x plus 3 plus 2 over x squared minus 9. Step number 1, always factor. So we've got 5 over x plus 3 plus 2 over x plus 3, x minus 3. So if we look at the denominators, I've got an x plus 3, I've got an x plus 3, I've got an x minus 3. Well, x plus 3, x minus 3 is together. I have to at least have that. And then I look at this one. X plus 3, oh, that's already there, so I don't have to add it in again. For the second one, I've got the same new denominator already, so it's just going to be a plus 2. But this first one, it was missing an x minus 3 here, so I'm going to multiply it by x minus 3 over x minus 3. Now I get 5 times x minus 3 for the first numerator. Distribute that in. We got 5x minus 15 plus 2 over x plus 3, x minus 3. Combine that together. 5x minus 13 over x plus 3, x minus 3. Look to see if you can refactor the numerator. We can't, so we're done. Just NPVs left. Take all the denominators. X cannot equal positive and negative 3. Done. So all that this is saying up at the top of the page there is, hey, the same strategies we used for monomial denominators is going to be the exact same strategy for binomial and trinomial denominators. All right, so applying exactly what we just did to these new questions. Same strategy. What do we have for denominators? I got a p minus 2. I've got a p plus 1. Both of those have to be in the new denominator. So we got p minus 2 and p plus 1. Well, what's the first fraction missing to be able to get us here? Well, it's missing the p plus 1. And I have to multiply numerator and denominator by it. because I have to multiply by a form of 1. So I have an equivalent fraction. P plus 1, that's P minus 1, plus, the second fraction is missing the P minus 2. So we get P plus 3 times P minus 2. Expand the numerator for both parts. And we come up with P squared minus P plus P minus 1 plus, that's the first one, plus P squared minus 2P plus 3P minus 6. All of that over P minus 2, P plus 1. Collector-like terms in the numerator. I have a positive, so I can take the brackets right out. I don't have to distributing a negative or anything like that. So I can just go P squared plus the P squared will give me 2P squared. Then I've got P minus 1. Minus P plus P, gone. Negative 2P, 3P gives me plus 1P. I've got a negative 1 and a negative 6, minus 7 over P minus 2, P plus 1. Don't expand the denominator, leave it. And now we go and look, can we refactor the numerator? Remember what I gave you as a little trick? B squared minus 4AC. The discriminant has to be a perfect square. If this is factorable. And if you put the numerator into that, you get 57, which is not a perfect square, so it's not factorable. So we can't go any further with it. So we just put comma our NPVs. All the way through any denominator that we have to use. So P cannot equal negative 1 and positive 2. There's our final answer. Trying B. This one we got to now factor. And there's a little trick involved in this one. So we've got 2 over e minus 3 minus 3e over 3 minus e, 3 plus e. Well, 3 plus e, that's the same thing as saying e plus 3. Doesn't matter which order I write them in. So I'm just going to write e plus 3, because we like to put the variable first if we can. But this one, 3 minus e, that's very similar to here, but it doesn't have the same sign. So I'm going to factor out a negative to change both signs on this one. 2 over e minus 3 minus over. So if I factor out a negative, that's going to leave me with 3 plus e. Sorry, negative 3 plus e. Well, negative 3 plus e, let's change the order of that one. E minus 3. I still have that negative sitting in front. So now, 2 over e minus 3. I've got a negative and a negative. That's going to change it into plus now. Plus 3e over e minus 3, e plus 3. Now I'm ready to start adding them together. I can now get a common denominator. So the trick here is that you had to notice you needed to factor out a negative 1 from 3 minus e to switch both signs. Well, my common denominator, I've got an e minus 3 and an e plus 3, so those ones for sure have to be there. Now look in the other denominator. Oh, I already have an e minus 3, so I don't have to add more. The common denominator is the same as this denominator, so I've got a plus 3e still sitting there. My first fraction, I need to change to an equivalent form. It's missing e plus 3. So now I have 2 times e plus 3. Distribute in your 2. 2e plus 6 plus 3e over e minus 3. E plus 3. Combine all of your like terms, and you've got 5e plus 6 over e minus 3, e plus 3. Can I factor anything with the numerator? No. It's done. Just NPVs. Don't forget NPVs. E cannot equal. We got a positive and a negative 3. Plus and minus 3. All right, example number 2. We got factoring on the two denominators that we got to do. So the first one, 7 over difference of squares, x minus 7, x plus 7, plus 3 over. Factoring this one. If we look, it's a perfect square trinomial. So that gives us x plus 7 squared, which really means x plus 7 times x plus 7. So it's always a good idea, even if they give you a squared in the question, when you're doing these type, to write it twice, so that you don't forget about one of them. And now I need to look at what I've got. In the first denominator, I've got an x minus 7 and an x plus 7. I at least need that. Now let's go to the second denominator. I already have one of the x plus 7s, but I need another one. So then I've got to put another x plus 7 happening there. There's my common denominator. 3 different factors. The first fraction gave me the 2 yellow ones, but I'm missing the blue one. So I'm going to multiply by the x plus 7 over the x plus 7. That's the blue. The second fraction is missing an x minus 7. So I'm going to have to multiply by the x minus 7. And now expand your numerator. If you can, from right now, you can go ahead and distribute that in. If you want to rewrite it one more time, go ahead. I'm going to rewrite it one more time. 7x plus 7 plus 3 times x minus 7. Distribute it in. Equals 7x plus 49 plus 3x minus 21 over all 3 of those for a denominator. X minus 7, x plus 7, x plus 7. Combine all of our like terms on the numerator. We've got a 7x, we've got a 3x. That gives us 10x. 49 and a negative 21. So we're looking at plus 28 over x minus 7, x plus 7, x plus 7. Now we look, can we refactor the numerator? Yeah, I can take something out. I can take out a 2. So let's do that. Gives us 2 bracket 5x plus 14 over those 3. X minus 7, x plus 7, x plus 7. Every now and then, we'll be able to cancel off one of these from that factored numerator. Not this time. So last thing we want to do is just clean it up. 2 bracket 5x plus 14 over x minus 7. And I've got an x plus 7 and a second x plus 7, so now we're going to put x plus 7 squared. You could have done that earlier, but just make sure that at the end, if you have two factors that are the same, square it. Comma, NPVs, and plus and minus 7. It's always a good idea to try to get ahead of me here. Try it and then see if you can get it on your own. Let's go through these. First thing, numerators are factored already, so let's factor our denominators. N minus 3 over n plus 6, n minus 3, minus n minus 2 over n plus 5, n minus 4. Now looking, we've got 1, 2, 3, 4, and they're all different for the denominator. However, if we look closely, we can notice this. We want to always simplify and reduce as we're going along. Keep numbers as small as possible. I've got an n minus 3. I got an n minus 3. Those are packages exactly the same. I can hiya those ones. So now I'm actually just sitting with 1 over n minus 6. Or, sorry, n plus 6. Minus, can't do anything with the second, so n minus 2 over n plus 5, n minus 4. So now we've got the yellow, the blue, and the green. 3 different denominators, all of which have to be in our common denominator. Well, we got our n plus 6, n plus 5, n minus 4. So yellow, oops, yellow, blue, green. Color coordinating might help some of you when you're first starting out with these. And now look, what is the first fraction missing? The first one has the yellow, it's missing the blue and the green. So we got to bring those 2 in there. So that means multiply by n plus 5 and n minus 4. The second fraction is missing the yellow one, so it's missing just the n plus 6. Expand your numerators. Don't expand the denominator, expand the numerator though. So we get n plus 5, n minus 4 minus n minus 2, n plus 6. So expanding the first numerator, we come up with n squared minus 4n, 5n, so plus n, and minus 20. I'm going to put those in brackets, minus. Put these ones in brackets, n squared. We got a 6 and a negative 2, so plus 4n minus 12 over n plus 6. n plus 5, n minus 4. Distribute in your negative 1. to a second set of brackets. That now gives us n squared plus n minus 20 minus n squared minus 4n plus 12. N plus 6, n plus 5, n minus 4. Nice, the n squareds cancel off. We get negative 3n and minus 8 over n plus 6, n plus 5, n minus 4. Comma, and can't factor the numerator at all, so then just n cannot equal negative 6, negative 5, 4. But, wait a minute. Way up at the beginning, we canceled off an n minus 3. Do not forget about that one. Comma 3. Highlight that one, because that's the one that people are going to forget. Okay, for example number 3, you may want to look at the way that they're solving their example number 3 in the textbook. They're doing it more of a through words. I'm going to use a little bit more organized approach to it than what they're showing. Whichever of the two methods makes more sense to you, you can use that. And we're going to do a lot of these when it comes to 7.6, the word problems. On a canoe trip, Patton paddled upstream a distance of 10 kilometers, and a return trip downstream, average speed was 5 kilometers greater. Write a simplified expression for the total paddling time. Whenever we have these kind of questions, we've got distance, we've got speed, we've got time. This is a distance, speed, time. So distance is equal to speed times time, using the formula from science. We don't worry about saying velocity. We're not worrying about vector quantities right now. So we're just saying distance equals speed times time. The way that you want to set these up is by making a nice chart for yourself. Distance, speed, time. So we're always going to be starting like that. There's always going to be two different situations. In this case, it's upstream and downstream. Some of the questions that we get to might be car and bus, with the wind, against the wind. Lots of different ways of setting these up, but there's always two different criteria. Start by filling in the column that you are given the information for. Patton paddled upstream a distance of 10 kilometers. We know that upstream is 10 kilometers. On the return trip downstream, well, you're going up 10 kilometers. You're going to have to come back 10 kilometers to get to that same place. It doesn't tell us to go anywhere else except come back to where the starting point was. So I fill in what I know. The next thing, I have to figure out which column is the next one to fill in. And this is usually how we look at it. If I want an expression for total paddling time, that's going to be this column here, where I'm going to find out a total. A total is made up of on the way there and plus on the way back. That's the column that we're going to be using our formula for. In terms of average speed, that's meaning, they're telling you right there, in terms of means that's your variable. Your average speed upstream. So we're going to use a let statement. You need to get used to being able to use let statements. As soon as you bring in a variable, you need to identify what it is and define it. We call them let statements in math. We're going to say let x choose whatever variable you want. If you want to use s, you could use s, but we have to define what is this x meaning, and it's meaning the average speed upstream. So let x equal the average speed upstream. Lets the reader know what is the x mean. So the average speed upstream is x. But downstream is 5 kilometers faster. So that's going to be an x plus 5. 5 faster, 5 more. In that third column is where we have to use the formula. If you find that you're not using the formula, you know you're doing something wrong on these. I need to solve for t. So I'm going to rearrange my formula to be saying t is equal to the distance divided by the speed. That's the form I'm going to use in this one. So I come to here and I say t is equal to the distance, which is 10, divided by the speed, which is x. Downstream, do the same thing. The distance is 10 divided by the speed, x plus 5. And I'm looking for the total time, so it's those two added together. We now make our expression. Total time is equal to the upstream plus the downstream. And all we're doing is we're working with this exactly the same as we just did. Get your common denominator, which is going to be x times x plus 5. And then see, what do I have to multiply the first one by? X plus 5 over x plus 5. And the second one I need to multiply by x over x. So distributing in those 10s, I get 10x plus 50
Mr. Gillian, contact you.
plus 10x. And keeping that going, we got 20x plus 50 over x times x plus 5. But now we look at it and say, okay, for our NPVs, we would say, oh, x cannot equal 0 and x cannot equal negative 5. Well, first of all, what is x representing? X is the average speed upstream. Well, I can't have a speed of 0 going upstream, so I don't even have to state that. That doesn't make any sense. I can't have 0 for speed. How about negative 5? Well, I can't have a negative 5 for a speed. We're not talking about velocity. We're not worrying about vector quantities and direction. So in this situation, that doesn't mean anything. But I can say this, that there is a restriction on the x value. And the x value has to be a positive number. So I am going to have to identify that. So this just means that x must be positive. So logically working it through and thinking it through, the restriction is not necessarily based on what's going to make the denominator 0, although we still have to look at that. It's based on what makes sense in this situation.